This next section, 35.5, is the last section that's under the chapter 35 on refraction of light and lenses. We're going to discuss here three objects: a simple magnifying glass, then a telescope, and then a microscope. We'll see great similarities between these three. Obviously here we want to see something up very, very close, like a bug or a germ or virus or a piece of pollen. Here we want to see a star or a planet, and here we want to just see something in everyday life, like perhaps a newspaper with very fine print or a photograph where we're looking at something in a very simple situation. Let's first of all look at the magnifying glass. We're all familiar with a magnifying glass, and if we normally just think of how we see an object, we have an object out here, and here's the human eye, and the light comes in, goes into the eye at some angle theta. But now we can try to make this object look much closer by putting a lens here. And if we bring this, I'm going to squeeze this down now to imagine that this object is actually much closer. And what we're going to do is put a lens in here, and our situation is going to be more like this. We're going to take our object, which is going to be rather close, and we're going to put a lens here, put our eye back here, and the light from this lens is going to go straight through and bend down. Light from here is going to go through the center and go down. I guess the eye should actually be a little bit larger eye than I've got here. And if you look at this, it would appear, this is the object, it would appear that if we continue these lines, then in fact this would go out here and this would meet that object, perhaps out at a point like this. So this is the image that we would see. In other words, our eye thinks that this is a very large object, when actually it's a close-up object where the lens here converges some of those rays and it appears that it's further away but large. So the image that we see is quite large, much larger than the object itself. Now, this is how a simple magnifying glass works. Next, there's a formula here I might mention for the approximate magnification, where n is the distance to the near point of the eye. I haven't derived this, but it's an approximate formula that can be derived. 1 over the focal length minus 1 over the distance to the image multiplied by the quantity n, where n is the distance of the near point to the eye. Now I next want to look at a telescope. The telescope and the microscope are actually very similar in their appearance. For the telescope, we are going to have, let's draw it this way. We're going to have, first of all, what is called an objective lens. And then we're going to have something called the eyepiece. P-I-E-C-E. An objective lens and an eyepiece lens. And our eye is going to be back here as we look out. Here, when we have a telescope, we're going to be bringing in light from a great distance into this telescope. And as this light comes in, it will go through here and it will create an image. Let's approximately say here. This is a great distance. This is almost at infinity. So this is a planet or something like that. Very, very long distance. So this would be about where the focal length is for this subjective lens. Then this image is re-imaged, the light from this apparent image Then comes, we've got to make this a little bit larger, then comes on down here, is focused back into the eye. From here, goes back into the eye. This goes over, it goes in here. This goes straight down and goes over. This goes out a little bit further and comes in at 3 different points there. And what we see is as though the object is huge and it's out here. This is similar to what we were looking at before with compound lenses. So this is the image, and the image looks huge, and we got a great deal of magnification. And the magnification for a telescope can be approximately written, need to raise that up a little bit. The magnification is given by the negative of f0 over fe, where f0 and fe are these 2 points. If I look at precisely the distance between here and here, this would be f0. Let me write it that way. This is f0. It's going to be let me get that on the screen. f0 is going to be the focal length of the objective lens, and fe is going to be the focal length of the eyepiece lens. The next object we want to look at is a microscope. I'm going to bring this up just a little bit. And for a microscope, we have a very similar kind of situation. In fact, the diagram is almost identical. We take something, rather than being almost infinitely far away, we're going to take something that's very close. And then we're going to put an objective lens here. We're going to put an eyepiece lens here. It's the objective. Objective lens is used to collect and begin to bring the light together, to begin to focus it. And of course back here we have the eye that's going to observe. So here we have a very small object. If we looked at that, it would look minuscule, like the height of a tiny letter in a font, or a bug's head or something like that. And as this light goes in, we form an image over here. This is the object. This is the image. Then the light comes from this image, and it goes here for this one, out here for this one, and they both focus back into the eye. And the distance between these, it might be some length L, and it is going to be, of course, a rather complicated situation, but the microscope has a magnification which is approximately minus L minus Fe, where Fe is the distance, is the focal length of the eyepiece, and we have a focal length of the objective, minus L minus Fe times N divided by FO times Fe. And we're not going to derive this formula either, but it can be used to give you an overall sense of how we would do the microscope and compute its magnification.